We're going to bring up the presentation from Tish Robertson. Tish is the Water Quality Standards Scientist for the Virginia Department of Environmental Quality, Office of Ecology in Richmond, Virginia. She has been with DEQ for 15 years. In her current role, Tish provides technical oversight in the development and implementation of the Commonwealth's water quality standards. While at DEQ, she also serves as the Chesapeake Bay Program Analyst and a Water Quality Assessment Coordinator. Prior to her employment at DEQ, Tish managed a fish monitoring program with the Florida Everglades. She holds a BS in Applied Biology from the Georgia Institute of Technology and a PhD in Biology from Rutgers University. So please, everybody, welcome Tish.
Hello, everyone. If we can go to the next slide. Actually, let's go to the next one. I'm going to apologize up front. We're going to be talking about a subject today that we normally don't talk about right after breakfast. Oh, there you go. Okay. Forward and back. Okay. But I promise this is the most graphic slide in the presentation. And I also promise that that's bacteria in the background. So before I talk about what recreational bacteria criteria are, I'm going to talk about why we have them. Under law, all surface waters of the state must be in a swimmable condition. And we could define that in a lot of different ways. But in the realm of water quality standards, that means water quality that confers a low risk of illness caused by pollutant. And the pollutant that we're concerned about in this context is feces, fecal contamination, right? That's the leading cause of waterborne illness. And specifically the feces of warm-blooded animals, right? That's what carries human pathogens. So not just human feces, but also the fecal material produced by domestic pets, livestock, and even wildlife, right? Now, in theory, I guess we could develop a poop criterion, right? I imagine that that would be very, very difficult. So what we have done for many, many years, we use fecal indicator bacteria to build our water quality criteria around. So these are bacteria that are associated with the feces of warm-blooded animals, with the logic being where you see high concentrations of fecal indicator bacteria, you likely have fecal contamination. And so recreational bacteria criteria are legally enforceable. They're regulatory tools that allow us to protect water bodies and restore water bodies to a swimmable condition. Now, this group, most of us are very well steeped in, the sources of fecal contamination, right? Sewage is a big one, specifically untreated sewage, like the discharge that comes out of a combined sewer overflow, right? But you also have sources from livestock. So agricultural runoff can carry fecal material into streams. You also have situations like the one shown in that picture there, where livestock may actually do a direct deposit into a stream, right? They're there to cool off during the summer, but they're also, pooping, right? Even though there are people just a few feet away from them. So that's a source. Another source that's easily overlooked are wildlife. The feces of wildlife can transmit pathogens, so we do have to be aware of that. And then there's the dog in our neighborhood, right, that goes to the bathroom on the sidewalk. The owners don't necessarily clean up behind their pet, right? So in one sense, their owners being a bad steward of the landscape, right, they're littering. But in a more important sense, they are creating a potential public health hazard, right? They're degrading water quality because that fecal material will be washed into a storm drain and conveyed to a water body where people are swimming. Now, if you're anything like me, kind of goofy and immature, right? Like you see that picture and you might want to laugh, right? Because poop is funny and pooping is even funnier, right? We learned this on the first day of kindergarten. But there's nothing really funny about the illnesses that people contract from exposure to fecal material. So these headlines are in the news all the time. They may not be on the front page of the paper, and they may not be on the 6 o'clock news, but every day people are getting sick from swimming in polluted water bodies. One thing to keep in mind is that even though the recreational bacteria criteria are centered on bacteria, they're intended to protect people from a broad swath of illnesses, right? Not just bacterial pathogens like E. coli or Shigella, but also things like Giardia or Cryptosporidium. These are parasites that are spread by feces, or norovirus, which is a viral pathogen, right? Another thing to keep in mind is that people in general will have mild symptoms, right? Most people are not going to go to the hospital. They're not going to go to their doctor. I mean, they may be laid out for a few days, right? But it's something that they can manage. So their illnesses won't necessarily be reported to the local health district. And a lot of times people don't even draw a connection between their symptoms and their recreational activities because there is that lag, right, the incubation period. So there may be several days after someone goes swimming where they start to develop diarrhea or vomiting, right? So they're more likely to blame those symptoms on the food that they ate rather than their swimming. So we do have to educate people and let them know, hey, you can get sick from swimming in a polluted water body. Now, I promise I'm going to show you what the recreational bacteria criteria are, but I want to first take a moment to tell you what they aren't, right? We're familiar with bacteria thresholds in general. Not all bacteria thresholds are recreational bacteria criteria. You may be familiar with the work that the Department of Health does. So we have about 44 coastal beaches that VDH does weekly bacteria monitoring on, and they use bacteria thresholds to address a very important question, right? Is my favorite coastal beach safe for swimming right now? So VDH, like I said, they just focus their monitoring program on coastal beaches, but more importantly, their thresholds provide a real-time assessment of water quality condition. When you get an exceedance of the VDH bacteria thresholds, you get an immediate action, right? There's a swimming alert that's issued, or a swimming advisory is noticed in the paper, it's on the news, signs are posted, and depending on how many exceedances we're talking about, the beach may actually be closed, right? And all of these actions really are intended to protect people and let them know, hey, we have identified a potential hazard at this beach. You may not want to go swimming here, right? So that they can be informed. And, you know, like this couple, you know, they arrive to the beach. Maybe they decide, hey, this sign is telling us it may not be safe. Let's go down the road a bit, find another beach where we can swim, right? So the thresholds that VDH uses are very, very important, but they're not recreational bacteria criteria. In contrast, the thresholds that DEQ uses are recreational bacteria criteria. And they address a just as important question, but it's a different question. Over the past few years, was my favorite swimming hole safe for swimming in general? So DEQ monitors bacteria at all kinds of water body types, streams, rivers, lakes, reservoirs. We're not just focused on coastal beaches, but more importantly, our thresholds are retrospective. We're looking back in the past, and we're looking at water quality in a kind of a general overview sense. So we're not assessing a single snapshot in time. We are looking at, you know, a whole data set. And so you can actually have exceedances of recreational bacteria criteria and not necessarily have a problematic water body. It's the excessive exceedance that we look out for, right? So when you have an excessive exceedance of recreational bacteria criteria, we do inform the public. We're always going to do that, right? But we also inform resource managers so that they can do an investigation on the potential sources of fecal contamination in a watershed. And we, you know, initiate a cleanup plan and hopefully start installing best management practices like stream fencing to keep the cows or from accessing the stream and degrading the water quality there. So you can think of the thresholds that DEQ uses. You know, it's about protecting people, but it's also protecting the resource so that hazards don't even develop in the first place. Now, here are Virginia's recreational bacteria criteria. There's a lot of information here, so I'm going to walk us through it. There are two criteria elements. A geometric mean, which is a value that can't be exceeded at any time. It's calculated over a period up to 90 days in length. And then a statistical threshold value, which is a value that can't be exceeded more than 10% of the time over a period up to 90 days in length. And I'll explain later why it's worded like that. We do have some flexibility in that averaging period. And then so the rule is that these two criteria elements need to be evaluated over the same periods. And in order for you to say that a water body is meeting the recreation use, you have to demonstrate that that water body is meeting both of these criteria elements. We have two sets of criteria here. The freshwater criteria, we use E. coli as the bacteria. And then the brackish marine criteria, we're using Enterococcus as the indicator bacteria. And the numbers there are the magnitudes of the criteria. Now, if you're familiar with bacteria monitoring and assessment and you've been doing it for a while, you may be wondering what happened to the single sample maximum. And the single sample maximum was wonderful. We all loved it. It was really easy to use and implement. And the way it worked was a value that couldn't be exceeded more than 10% of the time over an assessment period. And at DEQ, we use a 6-year assessment period. So this shown here is an E. coli data set, right? So the way it would work is we've got our bacteria counts that we have, spanning multiple years. We're essentially looking at each observation, comparing them to the single sample maximum, which was 235. We count 5 exceedances of that. That gives us an unacceptable exceedance rate, and we would say, hey, this water body has way too much bacteria, it is impaired, right? That's how the single sample maximum worked. So where is it? Like, what happened to it? Well, EPA doesn't recommend a single sample maximum anymore. So in 2012, EPA issued updated recreational bacteria criteria, and Virginia has a policy of adopting whatever EPA recommends for recreational bacteria criteria. And we did this in 2018. And in EPA's recommendation, the single sample maximum was swapped out for the statistical threshold value. And people often think, oh, they're kind of the same thing. They're very different, and I'm going to explain how they're different later. EPA's rationale for this is that they believe the geometric mean criterion paired with the STV criterion provides better protection than using the SSM alone, which is what Virginia was doing for many years. Most states, I'm going to say all states were doing that. So that's why we don't use the single sample maximum anymore. All of EPA's nationally recommended water quality criteria are based in science. For the recreational bacteria criteria, the science that we draw from is the science of epidemiology. So there are several epidemiological studies that underlie the criteria, and they all had the same study design, right? You had a researcher that took daily bacteria measurements at a particular beach over some period of time, and at the same time and at the same beach, right, you had another researcher that was conducting a survey to all the people that were recreating at the beach, right, and essentially asking them to report whether or not they experienced gastrointestinal illness following their recreational activities. So if they gave like a 10 to 12 day window there to allow for the incubation period. And so gastrointestinal illness was defined as having one of 3 symptoms: diarrhea, nausea, and stomachache, or vomiting. So if you had one of those within 10 to 12 days of your recreational activities, that was counted as a gastrointestinal illness. And they surveyed not just the people that swam at the beach, but people that were just kind of chilling out on the beach. Maybe they were just getting a sun tanning or whatever, and didn't actually enter the water, right? And so EPA combined these two pieces of information and developed some model distributions of bacteria. So what we're looking at here is a theoretical 30-day distribution for E. coli that EPA believes confers an acceptable illness rate. And they define acceptable as 36 cases in 1,000 swimmers. So this is really important. You can go swimming in the most pristine water body that we have in the state, a water body meeting the recreation use, and you can still get sick. The criteria don't promise a zero risk. It just promises a low risk, right? So this theoretical E. coli distribution has a mean of 126. That corresponds to the geometric mean criterion element for E. coli. And then if you assume that standard deviation, then you can calculate the 75th percentile, which is 235. That's our old friend, the single sample maximum. And then you've got the 90th percentile that is the statistical threshold value that can't be exceeded more than 10% of the time. That's 410. So the way this works is we've got this theoretical distribution, and even though it's based on a 30-day period, EPA is allowing the states to assume that it also represents a 90-day distribution, and that's what we're using in the assessment program. So we want to collect at least 10 samples over that time period, right? And what we do is essentially using the geometric mean criterion with the STV criterion to look at the sample distribution, right? We can look at the distribution of samples on this slide and say, well, that looks like a water body that's in good shape because the mean of those samples doesn't exceed that theoretical distribution's mean of 126, and we actually don't have any instances where we exceed 410, which is the STV, the statistical threshold value. So we would say the water body where these samples came from is meeting the recreation use. In contrast, right, these two scenarios are indicative of a water body not meeting the recreation use. On the left, we've got samples that are consistently high. They have an elevated E. coli concentration. We don't actually see any exceedances of 410, but the geometric mean of the theoretical distribution is exceeded in our samples. So that would be not good, right? And then on the right there, most of the samples are pretty good, right, in terms of their concentration relative to the geometric mean. So the average of those samples meets the geometric mean criterion of 126, but you see on the far right there, we have two samples that are greater than 410. And with the sample size of 10, we would only allow one to be high. So we would say, yeah, there's too much bacteria in this water body, and so therefore that's evidence of impairment. Out of the two scenarios here, the one on the right is what we see the most often, right? During base flow, bacteria concentrations tend to be low, right? And then when it rains, if we just happen to be sampling right after it rains, we'll get spikes in the bacteria counts. So we see this situation a lot. There's a lot on this slide. I'm basically comparing and contrasting the assessment method that we use under the old criteria with what we have now under the new criteria. I'm going to skip down to the bottom for the sake of time and talk about exceedance frequency. So under the old criteria where we were using the single sample maximum, we would calculate one exceedance frequency, right, that would represent a water body over a 6-year period. Under the updated criteria, we calculate an exceedance frequency of the STV over all the 90-day periods where we have enough information, enough data to do that. So you could actually have multiple 90-day periods over a 6-year window where you're calculating exceedance rates. One important similarity between the old criteria and the new criteria is how we handle small data sets. So under the old criteria, if we had a data set with less than 10 samples, but we had 2 exceedances of the SSM, we would say that's evidence of impairment. We didn't have to actually go out and collect 8 more samples to make that determination. Under the updated criteria, if we have a 90-day period that has less than 10 samples, but we have 2 exceedances of the STV, we're also going to say that's evidence of impairment. So I'm going to illustrate what I'm talking about here with this hypothetical bi-monthly data set. So we have 24 observations here. Under the old criteria, right, where we're using the SSM, we would say we've got 1, 2 exceedances of the SSM. That gives us an acceptable exceedance rate. It's not greater than 10%. So we would say that the water body where these samples came from was meeting the recreation use, right? That's under the old criteria. Under the updated criteria, we would say this data set was evidence of impairment, because if you notice, those 2 exceedances of the STV are closely spaced. They're within the same 90-day period, and that would constitute evidence of high bacteria, suggestive of, you know, a distribution that's not conforming to that theoretical distribution. So the updated criteria in this sense is a little bit more hardcore than what we were doing with the old criteria. But here we've got a different data set. Under the old criteria, we would count 3 exceedances of the SSM. That gives us an exceedance rate greater than 10%. So we would say that's evidence of impairment. Under the updated criteria, though, we don't have enough information. And the reason why we don't is because there are no 90-day periods in this data set where we have enough samples to calculate a geometric mean. And we have to have a geometric mean to say that the water body is meeting the recreation use. Also, we have just 1 exceedance of the STV. We don't have any closely spaced exceedances of the STV in this data set, so we can't say there's evidence of impairment either. So we would say that this data set just there's not enough information there. That said, if we had an older data set that we could assess, right, and it had, you know, it demonstrated impairment of the recreation use, we would continue to roll that designation over and essentially wait for a data set that would allow us to show that the water body is meeting. So we always roll over impairment designations. So you may be wondering, okay, under this new way of doing things, how are we going to use monthly, bi-monthly data sets, right? And as I showed in the example before the last one, we can use these data sets to identify some impaired waters, the impaired waters where we do have closely spaced exceedances of the STV. But we do more than just assessment at DEQ. We also are doing cleanup plans and implementation plans, right? And a part of that is tracking progress. So we can use monthly and bi-monthly data sets to track whether or not the stream fencing that we've installed is really doing a good job of decreasing bacteria concentrations. We also do trend analysis. Every 6 years, we do a trend analysis on about 450 stations across the state for a whole suite of parameters and pollutants. So here we're looking at the trend results for E. coli at our trend stations. And we look over a 20-year window, right, to see if things are getting better, are they getting worse, or are they staying the same? And we see at most of our stations, we're not seeing any significant changes in E. coli concentrations. We are seeing some watersheds where we're seeing decreases, degrading water quality, where the bacteria concentrations are actually going up. And so this analysis would allow us to identify those watersheds that might need some tender loving care, maybe some early intervention. The weekly, semi-monthly bacteria monitoring data going forward under the new criteria, that will be kind of the gold standard for us in terms of criteria assessments, because these kinds of data will allow us to not only identify impaired waters, but we also want to identify those water bodies that are meeting the recreation use. We want to tell both stories because the public does deserve to know where the high quality recreational opportunities are in the state, and we want to be able to tell that story. So we will be trying to get more of these kinds of data sets so that we can tell the good news and the bad news, right? So here is a map of the stations that we have scheduled for 2022 in terms of bacteria monitoring. We have a lot of stations across the state where we are collecting bacteria. We have most of those states, most of those stations are what we would consider low-frequency monitoring stations, where we're visiting the water body monthly or every other month, right? And so those are wonderful data sets. We can't do a full assessment on those data. We can only identify impaired waters. We can't say water bodies are meeting the recreation use with those kinds of data. The green stations there are the ones where we are collecting high-frequency bacteria data sets, so those would be weekly or every other week samples, and we can do a full assessment on those data sets. So the goal is, as we keep going, that we will add more of those kinds of stations to our network, because as I said, it is important for us to be able to tell both stories, good and bad. But as you can imagine, high-frequency monitoring is always going to be challenging and resource-intensive. So it's going to be kind of a slog for us to add more of those stations to our network. Now, you may be wondering, where can I find out what is the status of my favorite swimming hole? Well, at DEQ, we have a GIS portal. And if you click on that little link there, once you get the slides at home, you will be taken to a GIS application that we have. This is a really cool resource. You can put in an address in the little search box, and it will take you to a particular area, right, where that address is. I put in the address of where we are right now in that little search box, and the circle there is where we are right now. And if you look just south of us, there's a little creek called Rocky Branch, and I clicked on it and it got a little pop-up. And so if you scroll down in the little pop-up window that shows up there, you can see how we assess the recreation use. And we see it's not supporting, and that's because we have found high bacteria counts, specifically E. coli, in this stream. So this is a really good resource. I recommend everyone check it out to find out, what's the water quality in your neighborhood or in those water bodies where you recreate. And I hope we have some time for questions. I'd like to introduce Sandra Mueller. She's the Water Quality Monitoring and Assessment Program Manager at DEQ, and she is also here to answer any questions that you might have. Thank you. Oh.
One of the frequent questions that you receive is, could you please provide us with the equations that you calculate these STDs and geometric means with? Have you, and could you do that for us?
Sure. I have developed an Excel spreadsheet that you just copy and paste your data set in there, and it will crank out all the statistics that you need.
That's awesome. Could you also give the equation?
Yes, I'll give you the equation.
That would be awesome.
Mm-hmm. Yes.
One more. Hold on.
Oh, sorry.
I'm going to try to use the microphone so that we can capture the questions on audio. There you go.
All those data points you were showing across the state of Virginia, they were all done by Public Health Department? Yes, those. Or how many are done by volunteer groups?
So these are only DEQ stations. If I were to put like the citizen monitoring data, there would be a lot more dots on there.
Yes.
We do get a lot of bacteria monitoring data from citizen scientists.
What percentage are citizen scientists?
I don't have that number off the top of my head. Sandy, do you know?
Okay, thank you.
But it's a very important component of our assessment database.
I heard it was more than half.
Yeah, I wouldn't be able to say yes or no on that, but it's a good chunk.
All right, I think we have time for one more question, if anybody.
I think Karen has a question.
Doesn't look, oh, yeah, over here.
Yeah, from the map, we can see a lot of low frequency samples. And when it rains, normally the bacterial level spikes up. So how do you factor such reaction when it comes to bacteria in our streams, especially after the rains, which is when you really can really tell the level of bacteria? How do you factor that in your analysis?
We don't. I mean, we can kind of surmise that the spikes are due to a rain event, but we don't generally exclude those observations from our assessment. I don't know if we, do any factoring in when we're doing a cleanup plan, but, it's usually not right when, we're not actually taking samples during a rain event, right? It usually will follow a rain event by a few days. And people are recreating in the water body following a rain event. So I think it is kind of a representative data set. We want to capture those high-end exposures, even if they are due to rain. But that's a good question.
All right. Thank you, everybody. Can we give Tish a round of applause? Thank you so much.